Series of scenes taken from actual nuclear weapons tests in the 1940s, 50s, and 60s gives a quick look at a project being undertaken by the Department of Energy in cooperation with the Department of Defense to preserve and release historic films. The Department of Energy, in keeping with the administration's openness initiative, will use many previously classified and unreleased historic nuclear weapons testing films as part of its effort to detail an audiovisual history of the nuclear age.
There's the target. Bomb away. There it goes. The fourth atomic bomb has been successfully detonated. First you see a blinding flash. Then comes the hemispherical shaped cloud that expands rapidly just behind the initial pressure wave. After the smoke clears, the characteristic mushroom cloud begins to form and shoot skyward. From the explosion will fall for several minutes. Here again is an excellent photographic portrayal of the boiling, foaming wall of water engulfing the ships in the foreground. This highly lethal spray was intensely radioactive.
With test time only moments away, final time signals are called by Colonel Troy. Split seconds separate us from the detonation.
day, whatever you are, whatever you do, wherever you may go, you are a part of atomic warfare. It involves you, personally, in laboratories and in the field, in little-known places and ways. Units of the defense establishment of the United States are learning to work with atomic weapons, learning to strike, learning defense against the effects of atomic weapons. Blast, heat, light, radiation. The biography of every atomic cloud is essentially the same. The intense heat and violence of the fireball as it sears the sky causes the spectacular and colorful rust-like condition in the air around it. As the fireball cools, an enormous vacuum and afterwind is created, causing the desert floor to rise up into the cloud itself, to form the characteristic mushroom stem. The cooling also sets up a rapid condensation in the air around the fireball that sometimes produces layers of ice crystals, literally an ice cap. Knowledge gained on previous nuclear weapons tests has produced the theory that once the cloud has formed and stabilized in the sky, the vitally significant fission products in so-called unburned fission fragments don't distribute themselves evenly, but tend to collect in very large, invisible pockets, hot pockets, or cells inside the cloud. The particles that are suspended in these nebulous cells indicate many things that happen inside the bomb, as well as the efficiency of the fission reaction. So attempting to locate the cells and collect samples from them is a mission of the highest priority. Enter our display areas close to ground zero once RAD-safe okays us for the move up. Since the biggest value of the operation is for us to prove to ourselves that it can be done and find any weak points in the training, psychiatrists are with us to study our reactions before, during, and after the experience. It's quite an experience, no matter where you are to watch it. This kind of experience is immensely valuable for any military man.
Participation in Cactus supplied low-yield coral soil data for comparison with results obtained in Nevada soil from shots of similar yield. COA provided high-yield data for comparison with the low-yield cactus data obtained in similar soil. Successful measurement of neutron flux and spectra were made for a number of ranges. In the structural effects studies on the B-52, sufficient data were collected to substantiate a correlation between measured and analytical responses. This will establish a workable and reliable side-load computation procedure. Yucca, the first of the 3 high-altitude shots, was prepared and launched from the flight deck of the aircraft carrier USS Boxer. At 1125 hours on 28 April, when the Yucca balloon...
Ethan Allen submerged to firing depth. And there it goes. Polaris on the way with a nuclear warhead. Right on the second, the missile detonated at the intended altitude at the target point. The ASROC launcher lined up on target. The rocket-propelled ASROC headed toward target. In the foreground is the firing ship. 27 seconds later, the warhead splashed penetrated to its set depth. At this point, the service fuse completed the firing cycle and the burst exploded skyward. As the burst fell back, the base surge formed. A heavily radioactive cloud of spray and mist which spread to nearly 1 mile in radius. A few seconds later, the detonation bubble collapsed. This caused a new plume to be thrust upward through the primary cloud. And this impressive view of the shock wave spreading across the water was seen by the crew of another helicopter.
Stand by for Zebra Day. To the men of the task force, might unleashed by new atomic weapons is great indeed. But greater still is the might of a mighty nation working together. The Atomic Energy Commission's new proving grounds and these new tests were made possible by teamwork. And while this account stressed the story of the Navy's contribution, it was a contribution to a joint task force and to a united effort in Operation Sandstone.
In flight, the pilot will select an arm position. At release, a pulse of current is transferred from the aircraft to ignite the pulse thermal batteries. The parachute is deployed.
With over 6,500 aging classified nuclear weapons development films located on Kirtland Air Force Base, Albuquerque, New Mexico, and a smaller number at Albuquerque's Pantex plant near Amarillo, this joint Department of Defense and Department of Energy effort will preserve and allow appropriate release of this valuable historic information.